So now we want to find what the scale factor essentially is. So we're given some information here about how to do that. So the first step will be that you want to write the ratio of the model length to the actual length. Okay. And then we're going to simplify it so that the ratio has a numerator of 1. Okay. So let's try this out and see if we can make some sense of that. So in this case, we don't know what the scale is yet, right? How it's growing or shrinking, but we want to find out. That's kind of what the scale factor is. So we're going to write the ratio per step 1 of the model height, or length in this case, we're told it's the height, to the actual height. So a 6:72 ratio. Okay. And then we want to simplify the ratio so that the numerator becomes 1. Well, essentially, we're going to use a diva here, right? What can we do to both the top and the bottom so that we can turn the numerator into 1? Well, let's divide both by 6. 6 divided by 6 is 1, right? So we're essentially dividing by a 1 here. And to keep it equivalent, we have to do the same thing to the top and the bottom of our ratio. So as we divide, 6 divided by 6 is 1. 72 divided by 6 is 12. Doop, doop. So what does this mean? Well, we know that these were really 6 inches in our model height, and these were 72 feet in our actual height of this object, whatever it was. So our inches became 1 and our feet became 12. So we end up having a scale factor of 1 inch is equivalent, as you size it up or size it down, to 12 feet. All right, let's try another. So now we are working in the land of maps. So we have this sort of scale happening in our map, but we don't know what the scale factor is. So let's find out. So we're going to write the ratio of the model length. So the model length in this case is 36 centimeters to the actual distance, which in this case is 4.5. It can be kind of ugly to write fractions in fractions essentially. So I'm just going to turn it into a decimal. So 4.5 kilometers. Okay. So then, well, what do we want to do? It says we want to simplify the ratio so the numerator is 1. All right. So let's do that. We're going to essentially divide both by 36. 36 and 36. And when we do that, we end up with 1 centimeter on the top, and we end up with 4.5 divided by 36 using my calculator is 0.125, or in mathematical fancy talk, we could say 125 thousandths. But let's go ahead and, oh, kilometers, forgot the label. That's an important step here. So we have a 1 centimeter on the map is equivalent to an actual distance of 125 thousandths of a kilometer. Well, let's turn that back to a fraction since it started in fraction form here. So if we whoop this and turn it into a percentage, we know it's 12.5%, which really just means that you have 12.5 per 100, right? So if you take your 100 and you then divide it by 12.5, you end up with 8. You could also just set this up as a division problem because you know fraction bar is just a division problem. And you could do 1 divided by 0.125. And either way, you're going to see that you end up with 8. But not just 8, because we also essentially are doing the same thing to the top up here. So we have to remember that we also still have this numerator. So we did 1 divided by 1 essentially is still 1. And then in our denominator land down here, we've ended up with 8. So we end up with 1/8 of a kilometer is equivalent to a centimeter on